Alright, so we've been graphing parabolas and quadratics, and we found things like vertex and y-intercepts and stretches and shrinks. Today we're going to add on one new characteristic called zeros. Now you guys have already seen things called X-intercepts. X-intercepts are where parabolas touch the x-axis. There's another name they call these, and they also call them zeros. So whenever you hear someone say find the zeros, what they're asking for is they're just asking for the x-intercepts. And they call them zeros because these points, like this point is 3, 0, this point would be 1, 0. The y values here are always 0, and that's why they call them zeros. Where does your parabola hit the ground? If you think of this like a parabola going up and coming back down, where it hits the ground they call the zeros. And so if you ever see on a paper it says what's the zeros, they're asking for the x-intercepts, and the clue to find them is your y value is 0. So we're just going to look at a couple problems today where you actually have to find the zeros as well. So I think you got 2 problems on your notes page. The problems are going to look very similar to the ones we've been doing. They ask the same questions. You'll just notice at the very end they'll also ask for the 0. So it's just one more characteristic to look at. It's the last characteristic to look at if you're wondering what we look at. And they call them zeros again because that's where they hit the x-axis, that's where they hit 0. But it's also because that's where the y value is 0. So I want you to take a look at this equation right here. And imagine instead of writing y equals, I wrote 0 equals. So 0 equals x squared plus 2x minus 3. So basically all we did is we turned that y value into a 0, and now we solve it. That's how you solve or find the zeros. So this is all stuff we did last chapter. There's lots of ways to find zeros. You have quadratic formula, you have factor x, you have GCF factoring. I probably wouldn't do completing the square, but you could do square roots. So you still have to use those same skills. And so on this one I would look at it, and I could either do quadratic formula with a being 1, b being 2, and c being negative 3. But this looks like it might be factor x, so I'm going to just see real quick if I can factor x this. Can we think of numbers that multiply to negative 3 to add up to 2? If they exist, this is a lot easier. So 3 times 1 would be 3, so 3 times negative 1. So if we said 3 times negative 1, that would be negative 3. 3 minus 1 is 2. So that means I could rewrite this as x plus 3 and x minus 1. Now remember the ZPP part, you have to actually say what the x's are equal to. So x equals negative 3 for this one, and x equals 1 for that one. What we basically just found is where the parabola touches the x-axis. These are the x-intercepts. And so now when we go to graph it, we just have one more set of points to put on there. So if we go to negative 3 on the x-axis, that's this x-intercept. If I go to 1 on the x-axis, that's the other one. And so that's really the only new thing. It just gives us more points to look at than we had before. Everything else is still the same, so I'll just kind of run through it kind of quick, just so you guys have a video of it. When we do a problem like this, to find stretch, shrink, neither, we look at the number in front of the x squared. If it's a 1, if it's bigger than 1, it's a stretch. If it's smaller than 1, it's a shrink. If it's exactly 1, we just say neither. If this one is positive, it faces up and it's not a reflection. If it was negative, it would face down. Axis of symmetry is always found by opposite of b divided by 2 times a. So in this case, opposite of b, opposite of a positive 2 would be a negative 2. Divided by 2 times 1 is 2. Negative 2 divided by 2 would be negative 1. As you do more of these, what you guys are going to realize is the axis of symmetry has to be in between the zeros because these have to be reflected. So if you thought about where would be the halfway point between these 2 points, it would be -1. And so that just basically tells you that you did your axis or your x-intercepts correctly if they're exactly on each side of your axis of symmetry. Vertex again is a point. It's the turnaround point. Whatever your axis of symmetry is your x value for your vertex. And then you just have to plug in excuse me, just plug in that -1 into here. And so if we just come back up and zoom in, everywhere we see an x squared, or an x I should say, everywhere we see an x, we just take that x out and we replace it with whatever our vertex is. So in this case our vertex was -1. So we'll just come back up here and replace this with -1, and we'll just type it in our calc just like we have it, and that'll tell us where our vertex is. So none of that's new, everything of that is the same. All we did is add one small thing, and so I got -4 when I typed all that in. So my vertex is -1, -4. And then I would just plot that on the graph. So -1, -4 is -1 over and 4 down. You can now probably see the parabola, like it's pretty easy to see. But we also have a y-intercept. The y-intercept is always the c value. So I know my y-intercept is -3 or 0, -3. And that's where it touches the y-axis. So there's the y-intercept. Because this is a line of reflection, I can also put this point there. And now we really can see what our parabola looks like. So if you want to draw your parabola, just try to hit all the points. Make it a U, don't make it a V, try to make it more of a U shape. But the only new thing we really added today was this idea of x-intercepts. And again, to find the x-intercepts, we set our equation equal to 0 and we just solved it. So this is one where we could use factor x to solve. The next example is one where we would use maybe the quadratic formula to solve. So we'll do that one really quick, and then once you guys get the idea of it, I'll give you 4 of them to try today. And this will pretty much be the new stuff of our next unit, our next test, is just this idea of finding all the major characteristics and kind of going from there. So hopefully that made some sense, so we can do number 2. Let's start with the new thing again. Let's start with the zeros. And again, if you want to find zeros, just think of the clue in the name, 0. You're going to change your y value to 0. So we're going to say 0 equals 0.5x squared minus x minus 4. Again, that's this equation right here, just with a 0 up front. Now if you went to solve it, that definitely does not look like factor x because there's a 0.5 out front. The only way that I think we could really solve this is with the quadratic formula. So you are going to need the quadratic formula again. I'll make sure you have it. It's already on the board, I think. So it's x equals opposite of our b term. So you got to be careful what your a's, b's, and c's are. Here a is 0.5. There's not a number here for b, so that means it's -1, and c is -4. So x equals opposite of -1, so that would be +1, plus or minus square root b squared. So again, b is -1, so -1 times -1 is just 1, minus 4 times a times c. So you get good practice just going using this again. All divided by 2 times a. And if a is 0.5 or 50 cents, if you had 2 50 cents, that would just be $1. So 2 times a would just be 1. At this point, you just type in your calculator. So I like to type in the inside of the square root first. So if I just grab that and type in 1 minus 4 times a times c, and so the inside of mine would be 9. And so I just rewrite this as 1 plus or minus the square root of 9, all divided by 1. And then I would just go back to my calc and do both of those. So 1 plus the square root of 9, hit enter, divided by 1, it's going to stay 4, so one of my answers is 4. And then I just do 1 minus the square root of 9, negative 2 divided by 1, negative 2. So my answers are 4 and negative 2. Again, that's the only new thing today, and it's really not new other than what a 0 is. So when I find those, that's where it crosses the x-axis. Those are the x-intercepts, or where it hits 0. Even before you find AOS, you can probably start guessing where it is. If I just said, can you find the halfway point between these two ones, where would it be? Yeah, it'd be at 1. So we expect that our axis of symmetry when we get here is 1. Stretch, shrink, neither. So this is a 0.5. That's smaller than 1, so that's a shrink. It's positive, so we expect it to face up, so it's not a reflection. Our axis of symmetry, if you just want to write 1 and you're pretty confident that, you could, but if you want to double check it, it's opposite of B divided by 2 times A. Opposite of B would be positive 1. 2 times 0.5 is also 1, and 1 divided by 1 is 1. So we were right with that. Our axis of symmetry is at 1. And then our vertex is also then 1 over. And then when I plug in 1 into this, I think if I remember right, I get a decimal for this. So let's just do it. 0.5 times 1 squared minus 1 minus 4. So I'm just going to plug in 1 everywhere I see an x. And then I just type it right in my calc again. 0.5 times 1 squared minus 1 minus 4. And I get negative 4.5. So that means my vertex is 1 over and negative 4.5 down. So negative 4.5 is just in between 4 and 5. Y-intercept is always that C value, so the y-intercept is negative 4. A reflection point would be that point there. And we expected this one to be wider because it was a shrink, so as we go to sketch it, it would look something like that, a little bit wider than the other one. We really want you guys to feel comfortable with finding 1, 2, 3, 4, 5, all 6 of these major characteristics, and then once you find the 6, being able to put it on the graph. So like each one of these would be like a 7-pointer, making sure you can kind of do each one. If you guys need to go back and watch that video, please do so. If you have questions, let me know. Thanks.